Hello, everyone, and welcome to this webinar on SOLIDWORKS PDM data loading strategies. My name is Mark Young with XLM Solutions. Quick overview of XLM Solutions before we begin. XLM is a complete PLM solution provider. We've been around since 2005, so we have over 15 years of experience implementing PDM and PLM solutions, and pride ourselves for being highly respected in the PLM industry for both our business and technical expertise. We can provide tons of references for various customers within Dassault and SOLIDWORKS itself. We're also considered a SOLIDWORKS certified service partner, which means we're not a VAR. We don't sell software, but we're recognized and certified by SOLIDWORKS to provide professional services on their solutions. We really dedicate ourselves through quality excellence, through continuous research, customer relationships, and new technologies. We're always looking at the latest best practices and trends and new initiatives within the PLM, PDM, and digital transformation industries. And we really provide all aspects of PDM, PLM implementations, everything from discovery workshops, general implementation, customizations, integrations, data migrations, which we'll be talking about today, and then training and support. So let's get into and talk about data loading strategies. Now, loading or migrating data into PDM can be a daunting task, though with diligent planning and thorough testing, the process can go smoothly. And today we'll talk about various strategies and best practices to ease that migration pain. We'll go over pre-migration data analysis, which is a very key part of any migration project, where we analyze and plan out how the data will be loaded into the system. We'll then talk about various data loading options that users can use to load the data, and talk about pros and cons for each option. And then finally, execution of the data migration, talk about testing, data verification, planning for the final data load, and then the go live production data load. So the first thing with any migration is analyzing the data to be loaded. And I usually break that up into four buckets of what needs to be loaded. So we start off with reviewing the legacy data, understanding what is the data. Is it files folder based? Is it files in a folder? Is the data in a legacy system, a legacy PDM system, where there could be or most likely be a backend database, a file vault? Could files be stored inside the database? Is all the data available electronically, or are there actually physical hard copies out there that may need to be scanned? What types of data are we dealing with? Are we dealing with CAD data, pure metadata like bills of materials, non-CAD data, which could be Office files or PDFs or JPEGs? So what type of data are we dealing with? And specifically with CAD, we'll most likely have to deal with links and relationships, between the different data files. Next, after kind of that review is done, we have an understanding of what data we're dealing with. Next, we need to look at, are there going to be any issues accessing and extracting that data? So are the sources available? I mean, can we get to the source data? If it's stored in a database or a legacy system, can we get access to that database? Can we read the tables in that database? In most cases, the answer is yes, and because we're extracting data from a system that a company owns and you can get access to it. But sometimes, maybe it's companies that are diverging or merging, or there's a partner company involved and you don't always have access to all that data, or you can't get full access to the data, so you need to come up with some creative ways to get to that data. Sometimes you need a third party. It's proprietary data, and there's no way, unless you're that proprietary owner, to get access to the system. So sometimes you may have to involve a third party to get access to the data. And then, is all the data there? Could there have been, failures over time where data is missing, data wasn't put into the system properly, et cetera, which would result in missing data, and how should that be handled? Though, the short story is, if the data is not there, there's not much we can do. But maybe it is there, just not readily accessible, and we can come up with creative manners to get to it. And sometimes we need to provide or bring in additional experts. Sometimes, because of the different systems, different technologies being used, additional experts need to be brought in to help with the system. Then we get into mapping rules. And really, how is the data going to be mapped or placed into SOLIDWORKS PDM? So there's, really three main questions, which could have a lot of details behind them, but three main questions that need to be answered. What is the folder structure? So how will that data be organized in PDM? How will variables be mapped from the existing data sources to the data card variables that are set up in PDM? And what are the state mappings? So how will data be mapped to various workflows and states in PDM? So sometimes those rules are very straightforward, and other times they're extremely complicated, again, based on what that legacy system is or where the data is coming to and how PDM is set up. And then finally, is there any other special logic we need to deal with, in cases where customers have mature PDM processes in place? Sometimes they have additional tools and processes set up that we need to mimic or make sure they work in a similar fashion in PDM that will involve some additional migration rules or logic. And then lastly is to look at the volume of data and estimate the amount of time it will be to load the data. So usually, and we'll talk about this a little bit more, usually when we do a migration project, when we do that final migration, we turn off the system on a Friday, load the data over the weekend, and turn on SOLIDWORKS PDM that coming Monday. Well, depending on the amount of data, it may take longer than a weekend for the migration. If the company has multiple sites around the world, we deal with different time zones, and that weekend time can get cut down. So at the beginning of the project, we should have a good estimate of how long it will take to do that migration, and make sure that we have a proper window to do it in. And if not, then we need to assess what will be involved to handle migrating data over a window that supports the end customer's requirements. So data cleanup. With any migration project, usually there's some data cleanup involved, and not only with migration projects, but in general, data can become messy over time, depending on processes that have been placed over various years, may lead to bad or incorrect data. So through a data migration project is always a good time to look at the data, run some reports on the data, and determine what needs to be cleaned up or fixed. And here I list a couple common scenarios that we run into. So duplicate part numbers per file. So you have two different files, but they both are pointing to the same part number. And do they truly represent the same part number, or did someone create the same part number twice, but they're really two different parts? Duplicate file names. We've seen with SOLIDWORKS data, washer1.sldprt 10 different times in a system. And do those washer1.sldprt, do all 10 of them represent the same washer, or are they all 10 different separate washers that should have different part numbers? So that's another common scenario. Missing or incorrect file attributes. So I say the key attributes usually are, part number, revision, and description. Does every piece of data that we're going to load has a part number, revision, description, or are we missing key attributes that need to be, filled in or set up in the system? Missing or incorrect file associations or links. So especially when dealing with CAD data, are all the relationships between the CAD files correct and valid? Do you have assemblies that can't find its children components, or drawings that can't find its model files? File revisions not being current, depending on how companies work. Are you always working with latest, or could you have assemblies pointing to non-latest revisions as children? So making sure that the structure of the data are correct regarding revisions. Same thing goes to non-current parts and current assemblies. So, do you have an out-of-date assembly pointing to a latest part, or the latest assembly pointing to a non-current part? And if so, how would you want to handle those situations? Non-compliance revisioning or version schemes. So in SOLIDWORKS PDM, you set up a revision scheme, whether that's alpha, numeric, or some custom revision scheme. Well, in your legacy data, do you have revisions that do not meet that revision scheme? And if so, how are you going to handle them? For example, in the legacy system, your revisions were numeric, but in SOLIDWORKS PDM, they're going to be alpha. So that may be an easy mapping to convert the numerics to their alpha equivalent, but maybe we need some more additional rules. And other data validate accuracy of other rules that may be appropriate for the situation. So there's lots of things to look at, but half the battle with data cleanup is determining what is not correct or what's bad, and then the other half is fixing it. But knowing what you're dealing with first is the key part. So we have utilities to review data, scrub data, not necessarily clean it up, but really report on issues and then, take the appropriate actions to clean it up. So with any migration project, I always say it's a great time to review your current business processes and how you're working with your data, how you're collaborating, and possibly update your processes to handle, your current state of business and best practices within the SOLIDWORKS PDM application itself. You don't necessarily want to set up SOLIDWORKS PDM to completely duplicate how your legacy system's behaving. You want to set up SOLIDWORKS PDM to best meet your business objectives as they exist today. So it's a great time. We run into situations where customers say, this is how the old system is working. We're going to create the exact same, fields and data and just map it one-to-one. And, I always say, let's take a step back. Maybe that's what you want to do, but, let's look at how you're working today. Let's understand how you want to, work tomorrow, how you were working yesterday, and set up the system to best accomplish it. And then we can, map the data accordingly to how, the best case implementation of SOLIDWORKS PDM is set up for you as an individual customer. A key thing, though, to understand, as migrations happen, a lot of times PDM will change or get updated accordingly to how data looks or behaves in the system. So with migration projects, a lot of times we say, okay, freeze how PDM is going to be configured, and then we'll migrate data into that frozen configuration. But in reality, that doesn't happen. PDM is configured, but usually it's still changing as we're migrating the data. In any case, whatever the PDM data model changes, a variable changes, a workflow changes, it's really important to re-verify the migration process. Make sure that the change to the data model won't affect the migration process, and test it accordingly. So with any migration projects, it's always a balance between time to do the migration, cost of the migration, downtime for users, resources involved, both from a partner or the end customer itself, quality of data, testing time, etc. So it's a balancing act, and we're always here to work with you to determine what that best balance is between automation, manual entry, cost and time to develop or provide a solution to best meet our end customers. But in life and with everything, there's always trade-offs, and it goes with migrations as well to be aware of. So let's talk about some different ways we can migrate data into PDM. The first one that we talk about is simply manually dragging and dropping files from a network folder structure into PDM. And it's very easy to do. There's very low to no migration or service cost. If the files that are referenced are in the same folders, it will automatically build those those file relationships between CAD files. And if you have CAD mappings set up within PDM, it will automatically populate the data cards in PDM with the CAD mappings. So good, easy way to load data. Though the cons are you can really only load latest revision. There's no good way to load multi revisions of the file. If properties are not set up in the file properties, or they're not consistent, and you don't have data card mapping set up, then the properties don't get mapped over the data cards, and that could be an issue. The data getting dragged over will mimic the current folder structure you have today. So if you want to organize the data in different ways, you're not able to do that during this process. And then once the once the files are copied over, you still have to manually check them in and perform a change state on them if applicable. And finally, if you're dealing with large amounts of data, it's not, things can go wrong when you're doing it manually. So it's not really great to do on large sets of data at one time. But in essence, you could easily select a folder, drag it over, and check in all the files. So the next thing we talk about is custom scripts and programs. So again, this is areas where we get involved in a lot of times. And really, you can write custom tools to migrate data over into SOLIDWORKS PDM. It's really best suited for large data migrations. When we do the migration, we can manipulate both metadata and files at the same time. So we can set part numbers, we can set metadata based on various data sources. We can configure where the files are being moved to, what folders they're going to PDM, change the references, change the file names, really do a lot of data manipulation. Sorry about that. In addition, we can have the code support custom logging and error handling, so any non-conforming data can be logged and conformed appropriately. This is really, custom programs are really suitable for implementing complex data loading scenarios. We can support really any data loading role under the sun. Like I said, dynamically determining where the data will go. If the file starts with A, create a folder called A and put the files in there. If it starts with D, create a folder called B and put the files in there. We can reformat the data. We had a situation where a customer had different TIFF files that each represented a sheet for a drawing that were separate files, and we could merge the TIFFs together into one single multi-sheet TIFF and use that to load the data in. Obviously determine or update revision numbers, workflow states, really any data loading rule under the sun we can handle. Then there is, and in a lot of cases, this is what we do, make use of pre-developed data migration tools. So we have a set of tools that we use for migrating into PDM, and then we can tweak those tools to handle specific customer migrations. So a lot of the tools that are out there can handle full revision history, can have configurable attribute mapping, handle different events and logging and more. And like I said, we have tools to handle migrations from SolidWorks Workgroup, Smart Team, Autodesk Vault, DBWorks, PDM to PDM. So many times we have customers that want to merge their PDM vaults together and we can handle it, etc. So we have a lot of existing tools we can use and configure to meet existing systems and their migration needs. Another tool that we make use of a lot is the SolidWorks PDM XML migration tool. So this is a tool from SolidWorks that's used to load data into SolidWorks PDM. And basically, it takes an XML file, and we or you would be responsible for creating that XML file. But it takes an XML file and then uses that to load the data into SolidWorks PDM. Though this tool, there's some gotchas that you need to be aware of. One is it can only handle one-to-one mappings of variable data. So if you had description and you want to map it to, let's say, description, title, and description 2, it couldn't handle that. So we would have to configure something to handle that. Also, it only works in one revision scheme. So if you had multiple revision schemes, like a numeric revision scheme and an alpha revision scheme, there's some issues with that. We just need to work with the alpha revision scheme. The tool loads data in batches of 1,000. However, if there's a crash within a batch and it's known to happen, it could, that whole batch of 1,000 could be messed up. So we got to be careful to making sure that the tool can run clean, and if there are errors, know how to handle them properly to handle the, let's say, 1,000 or sets of thousands of data that may not get loaded. Revision values, you need to have the correct revision values in place, or revisions may not get set correctly. Again, that's part of the implementation of the tool, but something to be aware of. And this XML import tool follows all the configured PDM rules. So for example, if you were loading data to 2 different states within a workflow, you would need to make sure there was a transition from one state to the other state to allow the files to go into that correct state. It needs to follow the rules configured within SolidWorks PDM to work. And then finally, performance. I mean, the tool works, it's great, it's supported by SolidWorks, so if there are issues, SolidWorks is there to fix them, but to be honest, it's not the fastest tool, and it takes time to load the data because it's reading the files and analyzing the data as it gets loaded. So we need to be aware that for very large migrations, performance may be a factor, and understand how we can deal with that. Another thing to consider is delta migrations. So when dealing with very large migrations, sometimes you can't load everything in what we consider a big bang or a single migration. We need to perform a delta. So we recommend to do a single migration, load all the data in one big bang, like I said, over a weekend. And if there's performance issues, etc., consider hardware improvements, whether that be SSD drives, breaking the database and the application server across multiple machines, increasing the memory on the database, etc. Though, however, if that still doesn't let you migrate all the data over, let's say, a weekend, and we've run into such situations, we can handle delta migrations. In that case, we would load a majority of the data over regular business hours while the users are still using the legacy system, and then do the delta migration over a weekend or that downtime period. So the SOLIDWORKS XML import tool that I showed you can handle delta migrations. You just need to have the file name and the version comments in it be the same. And make sure that XML tool is split up appropriately so it understands what was loaded or what needs to be loaded. And with anything, if you're going to do a delta migration, not only test the full migration, but test the delta part of that migration along with it as well. So testing the migration process. Testing as part of data migration is extremely important. You really need to test the full migration process, mitigate any issues found, whether it's issues dealing with legacy data, missing data, issues with how you're loading the data. Maybe you have an invalid revision scheme. Maybe you're trying to load characters into an integer field, and then fix the data accordingly. Whether that's manual cleanup, changing the data loading rules. Maybe if you're trying to load a character, into an integer field, you change the data model to support characters. Or maybe you change your extraction rules to say, if it's a character, filter it out. Don't load it. So there, there's various ways based on the issue to fix it and then retest. Maybe you have bugs in the data loading code you're using. Maybe it's just the order of operations that you're loading data is causing issues and you need to change that. So with anything, make sure to test the process. It's not going to go right the first time. Understand what went wrong, fix it, retest again. And also make sure to document your migration procedures. What are the various steps being done to load the data? At the very simplest, usually there's two steps, one an extraction step and an import step, but a lot of times there's other steps involved too. So with pre-data loading planning, you need to start when you're getting ready to do that final production migration. You need to understand, when will your legacy system be turned off? At this time, you should have a really good estimate of how long it's going to take to load the data, and can determine, can it be loaded during non-business hours? Does it have to be loaded during non-business hours? Could it be loaded in an evening, or do we need a full weekend to load the data? Really determine all the required preloading activities and events that need to happen so you're prepared for that production migration. And like I said, you should really have that document the data load sequence, so all the steps and who's responsible for doing the data loading. And obviously identify all the personnel responsible for the various parts of the data loading process. Who's going to maybe do the majority of the work, but making sure IT's involved for any IT-related activities. If someone's going to be on hand to test or validate the data after loading, make sure they're available and aware of what they need to do, etc. So the final data load, with proper planning and testing, the final data load should go smoothly. Make sure to follow your documented procedures, though allocate extra buffer time for unexpected issues, and make sure to prepare to support the new users in the new system. There will be a learning curve once you move over, and make sure there's some key users or people responsible to support them with questions. So with that, I'm going to open it up for any questions, and I'd be happy to answer any questions at this time. Please type in the questions if you have any. So the first question is, how long does a normal data migration project take? And the answer is, it really depends on the data to be loaded and what your data loading rules are. I would say a typical legacy system migration to PDM is probably a 2 to 3 month process, but that is, calendar time. It's probably around 10 days of billable work to configure the migration, perform multiple tests on the migration, and then do a production migration. Next question. Can you convert CAD data while doing migrations? So the answer is yes. We could convert CAD data while we're doing migrations. Whether you're converting CAD from one CAD system to another, or possibly upgrading the CAD to a newer version of that CAD system, or maybe manipulating non-CAD files, like I said, combining TIFF files together, or updating header or footer information in Office documents. So yes, that can all be done as part of a migration process. Though at the same time, we want to manage that migration process into simple and manageable steps and not do too many steps at the same time. So if you are going to convert CAD, and it always depends on the end customer requirements and scenario, but it may be that you'd want to break that up into two projects, where one project is migrate the data as is, and then the second phase of that would be upgrade to new CAD or convert to new CAD. So it depends on the end customer situation. So that looks like all the questions for now. But once again, my name is Mark Young with XLM Solutions, and my contact information is on the screen. So if anyone has any follow-up questions or comments, please send them my way. But with that, I will end the webinar. Thank you very much for attending.